Happy Monday, everybody. How's it going?
It's going well. Welcome, Hala.
Hi, Matt and Joe. How are you? Happy Monday.
Happy Monday.
Doing
Yeah.
great.
Yeah. So, for the audience out there, this is actually pre recorded, mainly because I'm going to be in Australia during the regular scheduled time, and live show is not an option at that point. So, I just want to get up at like 3 or 4 in the morning and do it there, which I don't feel like doing.
But it's still
So,
Monday. We are recording on Monday, so we're not lying.
Correct.
no, not at all. We'd never lie to you.
That's right.
So, that's awesome. Well, good to see you, Hala. For people who don't know who you are, do you want to give a quick intro?
Yeah, so my name is Hala Nelson. I am currently a math professor at James Madison University in Virginia. I'm from Lebanon. I started out with pure math, like math. Actually, I did abstract algebra for my master's in Lebanon, and then I came to NYU to do a PhD. I I loved abstract algebra and everything, but I wanted to move toward like real life stuff where I could use my brain to solve things that are happening right now. I did applied math. I did partial differential equations, which is still analysis, and I did material science. The silicon and kind of like the thin film materials that go in our devices. But I did mathematical modeling of that, so I was still like removed from real life, but closer than abstract algebra. And then I kind of did a postdoc at University of Michigan in Ann Arbor. I did imaging over there. You send a wave down the earth, part of it comes back, you measure it, and you want to reconstruct the subsurface. So that was cool. And then I came to JMU, and I wanted at JMU to do stuff that my heart, especially after tenure, because tenure in academia is freedom, and then you can really think about what it is that you can do. So I ended up doing kind of like soul searching and thinking, what is it that I want to do? And then I think data science at the time was blowing up, and I had no idea what it was. And people were like, well, if you know math, you know data science. And if you know math, you know data engineering. And in my mind, I'm like, oh, okay, I know math. I'm a professor of math. How come I have no idea what these people are doing? So I started digging in and looking, and then that literally started me on a different path. And I ended up doing AI and math for AI and all kinds of stuff now, like real projects. We work with a bunch of people in my city with the fire department, transportation department. We work with the military. We work with Department of State. So it ended up being like completely different. But this is like synopsis of the crazy path that took me here.
What prompted you to write the book Essential Math for AI? In the show notes, maybe we can post a link to that. But it's an O'Reilly book. O'Reilly was also our publisher. We were pretty happy to work with them. But like for you, what kicked off this project? I know you've done a lot of work to transition personally from the more pure math and then applied math world to this approach of data science and AI.
Yeah. So in academia, people apply for grants. They apply for National Science Foundation grants, NSF. They apply for NIH grants. They apply for DoD DOE grants, Department of Energy. At least in my field, this is where the money comes from. I noticed when I wanted to learn about data science and machine learning. In my mind, first of all, to me, they were just buzzwords. I didn't know what they were. So I picked up a book, and it was an O'Reilly Media book. It was hands-on machine learning for scikit-learn, and also another book. It was designing data intensive applications. These are two really good books. So
Mm-hmm.
anyway, I was like, I learned a lot from them, but I was like, wow, I want to give a class. Of course, it was. I could see a ton of math in there. It wasn't like explicitly said that part of this is math. And then I realized that, so I'm like, well, I'm gonna give a class on this subject, and I'm going to apply for a grant where I can integrate everything we need, like the bridge between data and AI and machine learning and math. I wanted to give a class that will be that bridge, a math class, but also I wanted to integrate, say you're taking a probability class, I wanted to integrate into that exactly where you use probability in machine learning or in AI models, etc. So I wanted to integrate into every single math class, which usually is completely disconnected from applications. I wanted that bridge to be in every single. So I wanted to use a book for my class. So I started looking for books like Math for AI. And I just couldn't find any book. And then the few that I found, they didn't say math for AI. They said like something related. And then I would look in the chapters, and it's still like, hundreds of pages of only probability, or hundreds of pages of only linear algebra, or only calculus. And again, there is no bridge. And to me, that was like, that's always a missing link. I feel like you're kind of like not telling the whole story if you don't tell students exactly what they're learning, how does it apply right now to real life. And to me, that needed to be told. So yeah, I ended up, I'm like, well, I did learn a lot from O'Reilly. I might as well, write the book myself. And I was at the crossroad. I'm like, should I apply for a grant or should I just write the book? I'm like, I'll just write the book. It's something that needs to be told. And I go to O'Reilly Media, and I heard back the next day. They're like, yeah, we're looking for someone to write a book on that. And I kind of didn't really fill up the full proposal in the beginning. And then I was talking with Jess, and like, okay, fine, I'll fill the proposal and let's do this. So that's kind of how it came to be.
And it's funny. I can tell you, I have kind of the inside perspective on how that went down. And so normally O'Reilly rejects most of their inbox. It's just like, all right, people submit proposals unsolicited. Most of them won't be very good. And then they saw yours and like, this is amazing. We've got to publish this book.
It's so funny because I was literally watching a movie when I got the proposal. I went on their website and I downloaded the form, and I only answered the questions that I thought I wanted to answer in the moment, and I left everything else empty. Like, it ended up being filled up afterwards, but yeah, I thought this books, it really did not exist, and I could tell after the book came out that the book did not exist before, and it really needed to be written in a way that never loses sight of the AI application, machine learning. And I also wanted to unify it, right? Because one thing about math, it's like a grounding. It grounds, right? It's not hype, and it's not like a naysayer. There's like the communities, I feel like there's like, yeah, this is amazing, this is gonna do everything we need, and this is gonna take over, etc. And there's the people on the complete other end of the spectrum. They're like, oh, it's just a hype, it's gonna die, this is just, just another dot-com bubble or whatever. And I feel like if you tell the story from the perspective of math, like math is either right or wrong. There is no BS in math, right? So it kind of grounds you in reality. It kind of like tells you exactly what it is, what it's capable of, what it's not. And it really isn't magic. It's just learning functions, learning probability distributions. So the nice thing about what I wanted to do was to unify all these like completely different models under one structure. And to me, math allows you to do that. It's like, it's all of these different models, they have one or two mathematical structures. If you actually know these structures, you would understand these like hundreds of models that are out there. Not in an operational sense. Operational is different than exactly how it works, and that. So that's kind of how it all started.
Interesting. So if we were to go through, okay, so I think we're in the unique situation where we have three math nerds. You both have PhDs. I don't, but I think we all have an appreciation for math. Like, what are the essential math building blocks for AI?
The essential, yeah, it's so I'm not gonna say the stereotypical probability, linear algebra, calculus. These are like stereo. It is true. This is all you need, but exactly what you need is like one idea is all of these AI models. Whether you're using them to classify, I don't know, images, or to write new text, or to predict a value, or to whether you're using AI models to do all kinds of decisions and predictions. So what the only thing you're doing every single time is learning either a deterministic function or you're learning a probability distribution. You're actually trying to capture, you have a bunch of data that you want to understand. If you kind of understand the function that's generating the data, then you can generate similar data. Or if you can understand the probability distribution that underlies the data, you can sample from the probability distribution and then get data that looks similar to it. So all of these models, there are two schools of thought, and they work, both of them. I like the probabilistic, even though my training isn't deterministic. But the probabilistic, I feel like it's just like the nature at a minuscule level. It really is probabilistic, and to me, if nature is like that, then maybe these are the right models. But the ideas are exactly the same. Is you're either learning a deterministic function, in or probabilistic or probability distribution. Now, what each model, say you have support vector machines or a random forest or a neural network, what all of these differ from each other is exactly what assumptions on the function that you're trying to learn, or the probability distribution that you're assuming ahead of time. Once you see it that way, oh, they're just changing the function from this model to this model, or they're changing their assumptions on the probability distribution from this model to this model, or they're changing the way they're minimizing, they're optimizing, they're minimize the error between the data and the prediction. They're changing the way they go about the minimization, or if they're like function that they're assuming or is not convex. You want to minimize. Some convex is easy, it has one minimum, but say you're using a function that's not like that, then are they relaxing it, making it so it's, once you see it from a mathematical perspective, it stops being like 100 different things and you're overwhelmed and you're dying. It starts being like, oh, it's this or that, and change it. Okay, now I see what's going on. Now, so this is kind of the story. I hope I answered your question. So to me, the building blocks are what are you learning? Is it deterministic? It's like how you classify these things, categorize or distinguish between what kind of model you're using and how you're going about what assumptions you're doing when you're attacking it.
Let me ask you this. This is a pretty open-ended question and maybe kind of a loaded question too. But say I'm an 18-year-old, or say I'm early, in college, and I want to get into this discipline of, say, AI generically, let's say large language models more specifically. What would your advice to that student be? Like, what should they study in the university, and what should they do outside of their university curriculum to build their career?
Wow, it is a loaded question.
Yes.
It is a loaded question because academia and the industry have diverged, and academic disciplines between each other have diverged. Like in the past, a person who was a physicist was also a mathematician and a philosopher, and this was important, right? And an engineer at the same time. So if you read the history, the disciplines were not as divergent from each other as now. But they have diverged, and they have also diverged not only from each other but also from real life. So academic problems, like you go say into a math degree and then you have toy problems, right? You have problems like say with perfect data sets, or problems that are not that have nothing to do with the real difficulties that when you go into a company doing something you will encounter. So there's many ways where these things diverged. And then comes a field that suddenly is successful, doing amazing things. Everybody is interested in at the human level, intelligence, blah blah, and then this field suddenly needs to tie up all many disciplines together. You need math, you need engineering, you need computer science, right? And you need and these usually exist in different departments and different even colleges, right? So there is like the turf war, like no, AI is gonna bring so many majors. Oh, I want to do AI in my college, and I'm not gonna use any of these mathematicians, or I'm not gonna this is gonna steal my students. So it becomes a turf war, and in reality, you need. Your student who's 18 who wants to do this stuff. They need to learn from the engineering department, from the computer science department, from the math and stats departments, right? And of course, they also need discipline specific, right? So say you're in journalism and or then you all like say you want to like understand the news and make predictions, then you need like that domain specific expertise that you can't really give good answers without like the people who understand that domain and understand what they care in it. So what I'm trying to say in a very short, this is very multidisciplinary, and the person they in that sense need to like curate their classes to get this kind of expertise. Like they need to pick from each department. And now like finally both the government like NSF and academia are starting to realize the value of bringing all of this back together. And so NSF is funding a lot of projects where students are solving problems directly given from the industry. We work on that, and the uh, universities at a higher level are starting to realize that they need these interdisciplinary programs, and they need to put a lot of effort into building them. So I feel like nowadays there's a shift toward building these institutes within universities that are super interdisciplinary, but also are immediately talking to the industry and bringing problems directly from there. So people graduate with like relevant expertise. Because I mean, I did a PhD in math and I graduated with a PhD feeling like I had zero skills if suddenly I needed to go to the industry and I needed to teach myself that stuff. Does that make sense? So it shouldn't be like that. You should always tell students, this is what you're learning. You don't have to dive deep, say your class doesn't let you, but you tell students, well, this is, if you want to like venture into exactly what kind of problems they encounter, you can use these skills to like address them. And sometimes that's all what a student needs, is seeing like that bridge.
Matt, what was your experience? I mean, you got your PhD in math as well, and you became a data scientist. I mean, do you feel like your schooling prepared you for the quote real world, or what were some of the gaps that you had to fill in when you entered industry?
Yeah, no, I did not get the skills at all.
Yeah. Yeah.
Yeah.
I mean, my experience was probably similar, although I guess I had some kind of computing background just from before, sort of outside of my academic training. And
Yeah.
then honestly, a lot of my relevant experience actually came from physics. So I got a master's degree in physics before I went into pure math. And so I'd seen a lot of statistical concepts in that context. And in physics, they're used in a very, I mean, if you're working in string theory or something, it's very abstract. But even if you're studying something like thermodynamics or quantum mechanics, then probabilities become very, very concrete in a way that's useful for transferring to data science. But I definitely felt like there was this social capital problem where there just weren't enough conversations happening between people in data science industry and people in PhD programs in pure mathematics. And this is not the fault of the faculty who are trying to advise these students. They don't have those connections either. And so I think these academic departments in general just could really benefit from more conversations, even if I'm working just in pure math, just to be aware of what's going on out there and being able to tell my students and maybe make contributions here and there in a collaborative way, to your point, Hala.
Well, I mean, I see this too, though. I mean, we sometimes co-teach, at grad school. Matt and I do, and data science is taught there. And I feel like one of the things that's really missing is the industry changes very quickly. Right. I think expectations change very quickly, and there's a huge divide between the way I notice data science is taught. I think at a lot of schools, and the expectations of industry. There's quite a big disconnect, and I think the other thing I've noticed too. I mean, you mentioned tenure earlier, and I think tenure is an interesting one where it's good to have tenure if you're a professor. I think it also, from what I noticed, it has a potential of having a disservice to students, because if you get too much into your particular, you have no incentive really to change what you're teaching after a while, right? And I've noticed this in certain data science programs where there's tenured professors are like, well, I'm happy teaching, the stuff I've been teaching for a while. And in these cases, if we're talking maybe more technical curriculum, this stuff is actually quite stale from what I think we've seen. And so that's sort of the double-edged sword. And so but I think I'm starting to see departments definitely reach out to, industry. Like I'm an industry person through and through. I'm not academic at all. So that's where Matt and I are almost complete opposites in some ways, but we're best friends, so it also works out. But it is interesting, I think, noticing, kind of from the outside in, data science is, I think, slowly catching up to where industry is, but industry just moves super fast, right? So and it's not going to stop either.
No, it's not. But I feel like, I mean, first of all, that's another loaded subject that you touched on, the tenure and whether it's good or bad.
Yep.
I think you have a point in the sense that people don't want to update their courses. They don't want to put the effort, and it's an evolving landscape. And then the excuse they use, well, students need to know the principles. And okay, if you're focusing only on the principles, this is great. Principles last forever, and when they change, it's easy to change them. But part of it also could be like, it does take an effort to change the class, to change how you assess students, to change so many things that some people are just not willing to put the effort. And in that sense, it is definitely a disservice to students. But tenure as a whole, like for people who actually update their classes, who always like look for how they're going to benefit their students, it really is amazing. Like I couldn't do what I'm doing had I not had tenure. It would be very, so it's a double-edged sword, like you said. Something came to my mind and then it left it. I'll remember it.
Yeah, I think another thing I'd like to see more of is just an ongoing conversation between the academy and corporate America, like the tech industry. I think that's what's sometimes missing. And the reality is that it's easier than ever for students to get access to the latest tools because, 15 years ago, to stand up open source meant like buying a bunch of hardware and then having a place to put it and then installing the software. It was like a major, major undertaking. And now you just go to AWS or GCP and you spend something else. Yeah, but there's been a bit of a reluctance from the academic side to engage with those tools. And so I'd like to see more of that. And I'd also just like to see more of a conversation to say, okay, we're the experts on a lot of the principles, like we have training in math or statistics, but what are you doing day to day in your job as a data scientist or as an analyst or as a statistician for a major, say, aerospace company? And then make sure those conversations are happening and then you're integrating that feedback into the classes. But yeah, to your point, Hala, I mean, tenure can really cut both ways. It's like, on the one hand, it means a lot of people disengage after getting tenure, but it does give you a lot of freedom to do whatever you want if that's what you want to do. Yeah, what were you going to say, Joe?
Well, I mean, it's interesting. Like I'm working on a new course right now, and one of the things I'm really emphasizing is the stuff you're going to do in industry, like business requirements and talking to stakeholders and stuff that is not really taught at all, as far as I can tell. But this is where I notice, even if you have a technical background and technical training, you get into your first job, and well, guess what you're doing? A lot of times, you're not doing what you're trained to do. I think that's
100%.
the first realization you need to have
Yeah.
as a student is you, strangely enough, you might be talking to people and I don't know, figuring out what they want and maybe figuring out what to build. And so that's one of the things I'm really hitting on early on is just making it more of a simulator for the real world. So
Yeah, it's so important because it's exactly how I structured all my classes now. Like I take
it's cool.
students with me to talk to the head of the fire department, to the head of the transportation department, all the way above. Tell us what your goals are. And it's not only like this team doing this one thing. No, I want to know the vision and I want my students to see and participate in these conversations. And then they can design their solutions with like the goals of the whole organization in mind, and there's like what's the business value, like how are you doing it now, and why is how you're doing it now not working? Is it just you want to integrate the latest buzzword into your organization, or is it that you want to integrate, or is it that you really have a problem that the way you're doing it now is not being solved? And talking to the people at the highest level along with the experts in their teams, like the students participate in that, and usually they learn so much. I mean, it's so important to teach that way, and very few classes happen that way, but almost all the classes I'm doing nowadays, it's how I run them with my colleagues. I mean, there's a bunch of us.
That's
Yeah.
cool.
Yeah.
Nice.
It
That's awesome.
and they learn a lot, and they usually graduate straight into nice internships or straight into jobs because they've experienced the project all the way. They've gotten their hands dirty, but they've also talked about the business value and see and the book I'm writing now, the new one, is more on end to end because you have to tell the story that way. I mean,
Mhm.
otherwise we're all like in our little silos, developing the latest amazing thing or doing the model, like you should see in math, like the models are infinite. There's infinitely many models you can solve something with, whatever it is. And then some people just grab one model and start analyzing that one model to the rest of their life. And you're like, why? Like, exactly. I mean, first of all, that model has nothing to do with like reality, right? Like, so I'll give you, I'm not attacking other people. I'll give you the example
No, I
that
was going to ask for an example of this. So yeah.
yeah, I did in my own PhD, right? So it was a model about materials. Uh, I had so it was nowadays there's say superconductors or quantum computing and all of that. So the idea of what I was trying to do, or the problem that was given to me. I mean, it's coming from real applications, but it's like three or four. It's a model of a model of a model that ended up being one dimensional, right? As opposed to our life, which is three-dimensional, one dimensional, super simplified. It's true, I did math there and I did prove conversions found in energy, blah blah. But what impact did it have on the material science community? Zero, because I proved something that no one cared for, right? Because that's how much removed it is from real life. And
Mhm.
I learned my lesson, to actually pick problems that you know exactly what the impact. It's good to do that as an exercise, to learn some math, to learn whatever, just an exercise, but not to like dedicate your whole life to it and then vary this parameter and see what happens, etc. So it's good to kind of have a good understanding of the field and the landscape and the important questions in the field, and then kind of pick what you really want to invest your time and energy in, because time and energy are finite, and you need to work on things that are relevant, and relevant advance the industry. And Matthew, you were saying earlier about how your PhD, how physics helped you, kind of, and I feel the same in that sense. my PhD did me a favor for is to understand like materials at the minuscule level, like kind of look for what it meant and why. I mean, it matters a lot in manufacturing, and I'm putting that in my book, but I'm putting it again in exactly how it relates, as opposed to just throwing it out there and look how nice this looks or look how smart this thing sounds, right? No, you have to have relevance and you're manufacturing these devices. Well, what goes in the materials? Like, why do people care about superconductors? Exactly what happens on the atom, on the nanoscale, and so in that sense, if you tell it that way, then it becomes relevant. The same exact thing you're trying to do, if you tell it in different in ways that shows its relevance, then it's important.
Well, and I sometimes hear people claim that data science is just statistics, quote unquote, just statistics. And I think the important thing to take into consideration is that data science is like very connected to industrial statistics, and so it tends to be a little less academic. And so, doing things like not only talking about how devices are manufactured, but talking about how do we measure defects and how do we collect statistics on defects and what are the probabilities of different types of defects and what are the physical mechanisms underlying those defects and how do we calculate those. And I think that's pretty related to stuff you've done actually, Joe, with supply chain. But to me, that feels very, very connected to the stuff that data scientists do day to day, just like a lot of very concrete physics does.
Well, I mean, you're solving business problems at the end of the day, right? So it's
Yes.
so I mean, you have to have. I think when I got into things, I mean, I was originally going to be an actuary, and then I decided to just go into industry instead, and worked in sales, marketing, supply chain, I guess some parts of finance as well. Quote, data science. It wasn't just analytics. It was optimization problems and prediction problems and so forth. But it was so I mean, I had like the raw skills, even only having a bachelor's in math. I mean, that was, I think, adequate. As well as whatever actuarial training. But the thing is, the domain expertise I thought was like the harder part to get. Just understanding. I mean, you had these raw ingredients to think about problems and solve problems, but without the accompanying domain expertise and understanding how things work. I think that was a harder part for me, but you figure out what you got to figure out. It's not like you're just sitting there like, oh, I can't figure this out, I'm too dumb. I mean, you'll figure it out. I mean, so, or if you don't, you'll know really quick you won't have a job. So that's all that is.
Yeah, I mean, that's the important thing, is to actually go about figuring it out. Like, ask questions, talk to the people who are domain expertise, who are in the industry, whether they don't, if they do it technically or not. Just talk to people and see how they go about things, what they value, and what's the history. If people who know the history of the industry are very useful people as well, because they've seen things come and go. So these conversations, like, if you isolate yourself in one place, you're just gonna stay there forever, and that's not a good thing. Yeah, things move all the time. You need to, like, and then it's not much. I mean, it sounds overwhelming from in the beginning, but it's not if you're only focused on the principles of things until you actually really need to do the thing yourself. Then you dive in. But if you're like learning and talking to people, you don't have to know all the details. You just want the big picture, and then once you need to work with it, then you learn more and more.
So let me ask, you mentioned your new book, and I actually had the privilege to kind of review an early draft of the proposal. So I saw that project a while ago. I'm sure it's evolved a lot since then. Tell us more about why you're writing a new book, what it's going to be about, and maybe when we can expect to see it.
Yeah, so the new book. So first of all, I don't know what I was thinking when I signed the contract right after I finished the first book. So I don't know. I was not thinking that much in terms of like how much work it is. I'm sure you do know how much work it is. So, but now I'm in it, so I'm committed. So the book will be out in 1 year, exactly 1 year from now. Hopefully. I after I finished the first book, my first book is building the bridge between math and AI. Basically, if someone reads the book, they would learn a lot of math, just by trying to think about AI through AI, and then they would learn a lot of AI just by just seeing it through math. So it really is a bi-directional thing. It's not data though, right? And then at the same time I was writing that book, I was working with the fire department, transportation department, and the military. And they all had real data and a lot of data, and they all had very nice, super impactful questions. They wanted answers right now to it, right? Say where to locate the newest fire department. They had funding, they want to start construction, they just want to know exactly where, using the data, using the social, the type of people live somewhere, or the transportation department. They wanted to make their operations efficient, blah, blah. There's all kinds of stuff. Or the military, right? Blockchain. They wanted blockchain in the Air Force operation, right? So all of that. So I wrote the first book, but I didn't think that my book, the first book, would help people kind of see the overall picture, think in a high level, but they wouldn't help them in these kinds of projects. And at the same time, the transportation department, the data that we got from it, we finished the project, we were gonna go and present it to them, to the city council and all of that. And then we realized that the data that we were given was literally scrambled. Like the actual bus stops were not the data of a bus stop. Like that bus stop's supposed to be on a route, but it's not. Like they were like, this is a route here, and the bus stops are like all over the city, but they're supposed to be on the route. So basically everything was wrong. So it was horrible. And I did not know how to fix that because I have zero knowledge at the time of databases, on how data gets into the database and how does it, I had no idea of basically what you all do, like the engineering side of it, of data. And that's when I realized that there is steps before before you get data sets. There are steps before that, right? Like before an SQL query, you have to have, I want to know exactly how that pipeline works. So I realized that all my life I've been sitting in the middle, right? In the middle, where things come to you curated, and then you model it, and then you do proofs if you want, you do analysis, you answer business questions. But I was sitting like in the middle of the stack. But below is like the infrastructure, like the hardware, the databases, like the scale, right? Like accommodating scale, like talking about millions of people is very different than talking about 100 people, right? So all of that sits below the world I was living very happily in. And I wanted to that these two worlds to talk to each other. And then on top of me, which is the world that's above, is the world of business value, and what the board wants, and what the governments want, and whether there's funding or not, and how to prioritize. So there's a whole chain that needs to somehow be told in one story, and starting all the way from the hardware and infrastructure, going through the databases, the data engineering side, going through the models, the AI, the machine learning, or blockchain, or anything like gaming, right? All the gaming industry, everything is built on top of that infrastructure. And then how to go about it, and the math, well, it doesn't have to be math, whatever. And then on top of that, the business value. So I feel like this new book is necessary for anyone who finds themselves at the edge between one of these two worlds, and they know one side more and they want to know the other, and it's more like the whole story, the whole stack, basically. So, and I'll try to do it like I am doing it very simple, like not diving too deep to make people lost, but telling enough to give people a really good idea on how these things talk to each other, and when you need one. So anyone who wants to enter the field you are asking, this is great way to start. And so if they encounter what we encountered, not that I know how to fix it yet. I mean, I didn't really talk to them afterwards, but they would at least know exactly where things could have gone wrong in anywhere of this stack. And that'd be confident to model, to think analytically and mathematically. It builds confidence.
It's really cool. I feel like that's a huge area where I noticed that data scientists struggle is tying their training or their background to a lot of the technical aspects, right? You know, if you're not exposed to, I don't know, data pipelines, databases, and I don't know, data just sort of magically appears out of nowhere is kind of how
Yes.
I view that. It's just
It's a good
you know,
world to live in. I was
it's a
very
good world
happy.
to live in.
I was
Yeah.
blissfully ignorant.
Right. Yeah. Not every data set is like the Titanic data set.
Yeah.
You know, it's usually gnarly. So I mean, what you described with the bus stop thing, for example, I think that's like a really good example because that kind of stuff happens all the time, right? And so you know
Exactly.
better questions to ask once you get a data set like that. You can look at it. I think you start developing an art of seeing
Mhm.
um, data
Yes.
sets, for example, and kind of understanding it, not taking it at face value, but really you get
Yes.
better at things like exploratory data analysis, for example, and just being able to look at the data set and say, okay, so like, why are the
Yeah.
bus stops like not on the route? Why are they?
Yeah.
Like, what kind of bus system is this?
Yeah.
You know, so but if you don't have those skills, you're not able to translate it maybe back to the systems that create your data, for example, like your
No, you
well, they
can't.
run into what you just ran into. So,
Yeah, you can, and you also like, I mean, there's a lot of problems on down there at the database level and the even the hardware level that to me are just like interesting. They do take they're stimulating. They're to me they're also modeling in math, and but you're modeling not at the level where things are nice. You're modeling at the level where things are very messy, and someone needs to organize it. So to me, this is another reason I was like attracted to starting to study that. That's how I picked up your book, actually, Fundamentals of Data Engineering, and it's actually one of the reasons I picked it up. And then just trying to understand exactly what's going on in that world, and then you realize, wow, there's a lot of thought and modeling that goes in that world, which yeah, which I actually really enjoy.
Well, that's great. Thanks for the feedback. I mean, yeah, I've been working through your book as well. I haven't finished it yet. So when I finish it, I'll give any useful feedback I can.
are you one of the reviewers, Matt?
I am not one of the reviewers at this point. It's for book 2. So yeah.
For
Who are
book
your?
two, you are no, for book two, you are one of the
Oh,
reviewers.
okay.
You just haven't gotten anything yet.
Okay, it's totally fine. I'll review it when it comes
The
through.
first
So
book
yeah.
I sent it out like when it was a full draft, but this time I'm gonna send out more chapters.
Yes, and if you want
It's pretty
pre-reviews or
key.
anything, feel free to give us access. I think we're both happy to just
Yeah,
look
I
things
think
over
I
and
think
give
you count me in as a
feedback.
reviewer if you want one
Yeah,
too.
yeah.
Oh, that would be
So
awesome because yeah, so the first book I was telling you, yeah, so I I wrote it so I wrote it and I sent it like as a whole, and I realized that I should have been sending it in chunks, and because then you have to sit down and answer for the whole book, and you're like things you
yep,
wrote like a year ago. I'm like, yeah, really, I did write that. I didn't know. So so
it
now this
happens.
time it will be better.
So for people out there, it sounds really weird, but like writing a book has a sort of phantom limb effect, if you know what that is. Like,
Mhm.
you know, your arm's removed and you still think it's there. That's a lot like writing a book, and you come back to it,
Yes.
maybe you know, several months or a year later, and you're just like, what is that? Who wrote this? And you're like,
Oh,
oh,
you got
right,
this.
I did. I wrote that actually.
Yeah.
Uh, so it's yeah, it's I equate it to a phantom limb, also like kind of an out of body experience you know, at the same time. But so some advice if you're writing a book is when you work with reviewers, which you should always have reviewers. Uh, I'm a big fan of just chapter by chapter and letting people because you want that feedback early.
Mhm, mhm,
Um, and typically, you know, let your first chapter kind of ruminate too. Like that's actually the last chapter you want to come back to because
mhm.
that's going to tie your whole book back together. So like first
Yeah,
chapter, some people don't write the first chapter; they write everything except that, and they come back. But
yeah.
your first chapter is going to be hard, but yeah, just know like if you, because I review books all the time, you know, for O'Reilly especially, and I like doing it. I do appreciate as a reviewer if people can get the chapters and not just send the entire book, because you
Yeah.
got to be respectful of your reviewer's time too. And if you send an entire book to somebody, it's sort
It's
of nice,
always-
but it's also sort of like a white elephant gift that you just gave somebody.
Yeah.
And your review is
Um,
going to be superficial because you'll be rushed to get
Yeah.
through it. Whereas if you can just
You get
do
a
a
rush.
chapter at a time, you'll dig
Yeah.
in and give good comments. And the comments
Mhm.
shape the subsequent chapters. That's the other thing. Like you send chapter
Totally.
2, give
Yeah.
feedback, and they're like, "Oh, I should change this in chapter 4. I should rethink this outline." That kind of thing. Yeah.
Yeah.
Oh,
Absolutely.
totally. Like for me, the way I function is I always like when I see it from above and then I dive. So I end up like working on all chapters together and like refining the skeleton better and better and better. And then at some point I realized, hey, I have to actually write a chapter linearly. And I sit down. Yeah. So but it's hard for me to actually end up like doing a chapter totally linearly without like writing in all the others at the same time and refining. So but yeah, so this so that's one thing I had to like learn. I mean, it really, you learn a lot in these, and the reviewers, as I said, like my expertise, I am in the middle of the stack. I'm not hardware and infrastructure. That's not my expertise. Okay, maybe the materials and modeling, that's but and then the business value, etc., is also. So for me, it's so important to get that feedback early on, because these are the first chapters, are the ones that I'm like reading a lot to know what's out there, how
Yeah.
people do it, and then trying to summarize it, and I want to make it relevant to people who are in the field. So yeah, you too will start getting chapters soon. I'll be
Oh,
done
yeah.
with the first one.
Fantastic.
Well, yes, I think it's at least we can do. You're cool, but you know, it's definitely one of those things where I think you know, there's different ways to write a book. I think maybe, you know, there's but your reviewers are, I think, what definitely helps make a great book.
Definitely.
You know, I think we made it a point to, you know, I always talk about this. We made it a point to find I would say people that were almost scary, you know, in the sense where they were just going to beat you up pretty hard. But you really want that. You
Right.
really want people who are
Yeah,
going to just, you know, kick the crap out of you, because, like, trust me, the internet is a much more dangerous
definitely.
place. Your book will
I
get
want the
shamed
feedback.
when it's out. What's that?
Oh, totally. No, totally. And in academia, like we write and publish papers, so we're kind of used to like the kick, because people kick you more than not kick you. They always
Yeah.
like find so many things that they want done better, or they sometimes they tell you this is like playing wrong, and then you sit down, you're you really think either. First of all, sometimes you really are wrong and they're doing you a big
Yeah.
favor, but sometimes even if you're not wrong and they're saying like this is awful, it kind of fixes the way you present it, and that's still not a bad thing, you know. So you're like trying to like, you're talking, I mean, you know the stuff in your head, but you're trying to make it resonate with people, make it sound good. um yeah, like for me in the first book, the chapter on natural language, well, first of all, I've always worked in math, so I never worked in language before. Math is numbers right away. You don't really need to move from words to numbers and words that carry meaning. And I had no idea what they were doing when I was trying to write that chapter
Mhm.
on natural language. So I was reading like all these papers on natural language, like all the publications of the transformer and all kinds of stuff. And in my mind, I'm like, what are they trying to do? Like, I have no idea. Like, so I stalled. I stalled for a whole month from writing. I did not write. And then I was like really trying to read all this paper, trying to really extract exactly what they're doing and what's the starting point here, because I still cannot get the starting point. And then later
Mhm.
I realized again, it's like they're all trying to move words to numbers and make the numbers carry meaning. And again, it's how is each model doing it, and it's really how they differ. But the idea is always, was at least back, was the same for many of the models. And also in languages, so many dimensions. It's like how they are reducing the dimensions that's different from one model to the next to the next. And that's really a lot of them is how they're going about the reduction is what really differs. But it took me like a whole month to understand that. And then I got it, and then I sent it out to reviews. And yeah, so I was sitting there and like waiting for review for something that I just learned, and it was nerve-wracking. Like I actually slept in bed for 3 days, like just waiting to know what the reviews will be on
Oh,
this
really?
chapter. Like it was like really, really nerve-wracking. And it's rare for me to feel nerve-wracked after being in the academic world for a long time, giving all that kinds of talks to all kinds of audiences. But it was really like that it does. I mean, but you want the feedback, and the feedback was good, of course, but you do want the feedback, especially on this chapters. I mean, none of us is an expert in all the chapters, right? But you want the most feedback on the stuff that you really are not your like immediate expertise, and that's very helpful.
Yeah, especially I would say when your book hits Amazon, for example, right? Because it's like in academia, I mean, not
Yes.
too many people read the papers.
No one reads anything
To be
except the
frank,
reviewers.
it's like,
Yeah,
yeah,
maybe they
yeah,
don't.
10
I have a lot of
people,
questions
the
that
most
we should,
they care about.
exactly. So
Yeah.
the whole publish and perishing, I'm like, I don't know, I get it, but it's kind of weird because nobody reads
Yes.
it.
Yeah.
So, whereas if you have a book, the public, right? And that, and you can look at the book sales, and that's one thing, but there's also the especially in developing countries, people
Yes.
pirate PDFs all the time. So it's the number of people reading it, is easily thousands, maybe more, right?
Easily
Like,
thousands, yes.
yeah. I mean, we had the fortune and misfortune, I would say, of having a popular book, which also means like everybody's reading it.
Yes.
And I'm grateful to our reviewers for kicking the crap out of it, because I can only imagine if we sent our only draft out, we would have gotten,
Oh, same. Oh
rightfully
my
ridiculed.
gosh.
Yeah.
Same. Oh my God. Yeah, I can't imagine if I sent out the book before the reviewers. Like, I would have been like torn to pieces. Yeah,
Mhm.
it really improved a lot with many iterations. Easily the period of like 3 months was nothing but improving the book. And I
Yep.
really appreciate the reviewers, the editors, the proofreaders. Like, yeah, no, it's because like you said, I mean, sending it to 1,000 people and more is very different than sending it to the 10 people who know your field and know what you're talking about.
Mhm.
It's very different scale. And I also wanted to write something that's relevant for a long,
Yeah.
long time, and I mean, I didn't want to teach people a tool. I wanted to teach people how to think and how to see these. I mean, I feel like neither math nor AI nor data as a whole, unless they shut down the grid, none of this is going away for a while,
Right.
unless like, the power goes off, I don't know, the sun explodes or something, then not all of this is staying for a long, long time. So I wanted let people, to write something for people that they can use for a long, long time. And
Mhm.
that was and that yeah so that's and thankfully it's resonating. I'm grateful for the feedback that I've been getting. Super grateful.
Yeah. I mean, if I
Yeah.
look at my bookshelf now, I mean, there's Elements of Statistical Learning. I mean, that's like one of the classic books, and that's pretty old at this point.
Yeah.
I mean, statistical learning is what it was called. I mean, that's machine learning, but it used to be called that back in the day. Then I have Tom Mitchell's Machine Learning, the original book there from the 90s.
Yes.
It may have been one of the first machine learning books, but I mean, but all those are they're essentially math books, and I think to your point, they
Yeah.
carry their weight. So you can open up today, and it's like
Oh
there's
yeah.
nothing wrong. There's nothing wrong with them. The material, the chapter on neural nets in Tom Mitchell's book is probably old, because it was only a single layer perceptron at that point. It wasn't like deep learning.
Totally.
It
A
didn't
state
exist back then.
same
Yeah,
idea. Exactly.
yeah. But the
And
math
that's
still holds.
totally. And when people for me, the most annoying is when people start kind of fighting into, is this statistics, or is this math, or is this tool or that tool? And in my mind, I'm like, just step back one step and see what the functionality is, and then that's what's more important. It's not important the name of this, because the name is gonna change as time evolves. We don't speak the same language our ancestors spoke for a reason, because names change, but functionalities, necessities, what you need, what question you need to answer, what problem you're trying to solve, these have been pretty consistent for a long time. And that's another thing I want people to see. Like, don't get stuck too much in this community or that community. It's just see what people are trying to solve, if they're doing a good job at it, and learn the principles.
Yeah, I agree. And one thing I appreciate with your book specifically is that it's a math book, but it's very application focused, and it's conceptually focused as well. And so it's not just a bunch of like statistical exercises, but it's actually like, how does this work in practice? How
Yes.
are data scientists, machine learning engineers using these techniques, and what results have they been able to get out of it? And so I think it'll stand the test of time. I mean, I think it is going to be one of those classics that's around for decades, which in the tech industry, you know, to have a book around for 10 years is really saying something.
Yeah,
really
because there are hundreds of books, you know. If you want a good probability book, there's hundreds of them, and they're all amazing and good. If you want a good linear algebra book, there's hundreds. But that wasn't my goal, and that wasn't my point. My point, I mean, if you open my book, you actually read sentences. It's rare that you read symbols or equations, even though it's actually talking about this stuff and telling people. But that's also, I wanted to, I feel like I'm a mathematician at heart. You know, my dad taught me math since I was so little. So I've been doing math since basically I opened my eyes. But to me, math is not Greek letters and formulas, and these come after the thought and after what question and how you're gonna go about it, after the logic, you know. So I wanted to stay in like in the English and the logic, because if people learn that, then they can write the equations, and then they can, you know, write the programming and the software. But you have, when you understand the first thing first, and before diving into you know, hundreds of pages. Like sometimes some people say, oh, I got like there are some proofs out there are like 200 pages. And in my mind, you really think, like, to me, just hearing that a proof or math is 200 pages tells me that something better can be done. And whatever is done hasn't been optimal, because I think we all exist in nature, right? And we are a product of nature, and nature works in a simpler way than 200 mathematical lines, right? So I think it's back to the principles. It's more simple. And my point in both of my books is, if you go back to the principle, understand them, it's actually more simple than a lot of people are trying to make it to be.
I think it demonstrates true mastery of a subject too, when you can explain it very simple.
Yeah.
Right.
Yeah.
I think actually the sign that you don't really have expertise in a subject is when you need to obfuscate it and complicate it.
That's
You know,
totally what I think.
Mhm.
When you're trying to
Yeah.
show off, or when you're trying to scare people off, either you're trying to show off yourself, or you know, but you're trying to like gatekeep the subject, and you don't want to
Right.
gatekeep it, right?
No, not for books like this. I mean, these books are made for people that are, you know, trying to learn something new, right? So, I mean, if you want to scare people off, I guess have a 200-page proof, but you know, you'll
Totally.
still no copies, and probably not get asked to write another book by your publisher. So it's you know, but I think for O'Reilly, I know the bar is pretty high to become an author there. It's not like they just take anybody.
Yeah.
So
That
except
really
for happening. But, I'm just kidding.
We snuck through. We managed to sneak through. So.
Well, they told us not to do it at first. Or, you know, Jess was definitely like,
I still
thank you.
open my book when I need it. I actually need it for my new book. So yeah. So that,
please reference us.
of course I always do. Yeah. Now you guys are fun. I watch what you do on LinkedIn. It's the most site I'm actually active on. Yeah, so I see what you do. I really enjoy it.